Hello, Calculus 1. I want to start Chapter 5, Antiderivatives. Beautiful big chapter. A lot of topics, so we start with antiderivatives. But first, look at these problems here. I want you to take the derivative. So you know that if you take the derivative of this, we call it y prime, and the answer is 2x. You know that. Take the derivative of this, please, and you also get 2x because the derivative of the constant is 0. Right, okay. So the derivative of this is also 2x. The constant is 0. So if I ask you for the antiderivative of 2x, is the antiderivative of 2x, is it that, or is it that, or is it that? And the answer is this. The antiderivative of 2x is, it's not the antiderivative, it's an antiderivative, and it's this. It's x squared plus c, and this c is some arbitrary constant. So, makes sense, right? When you do an antiderivative, the 2x will get you the x squared, but there could be some constant there. There could be some unknown constant there. So we don't call it the antiderivative, we call it an antiderivative with this arbitrary constant. Now the notation to get that is this. It's this notation. I'm asking you for an antiderivative using this integral symbol. And I'm asking to integrate the function 2x with respect to x. So this is an integral symbol. In fact, we call this thing, and the answer is this. We call this an indefinite integral. And the phrasing and the words indefinite integral and antiderivative are the same. There comes a point where I kind of quit saying antiderivative. I start saying integrate. Let's do the integral. Let's calculate this integral. Let's do the integral. Let's do this indefinite integral. But all that means is let's do an antiderivative. We're doing the antiderivative of this function with respect to x. This kind of tells me the variable of the integration. We might do some with respect to t. We might do some with respect to some other variables. But this is with respect to x. So right now this is a notational thing. There's the function. We're doing the antiderivative, and it's x squared plus some arbitrary constant. So in general, the language is well, so this is one specific example. And then in the generalized notes, we say we're integrating a function with respect to x. We're asked to find the antiderivative of that function. And we refer to the antiderivative with this capital F of x. So the book will be full of this capital F of x plus c when you're just sort of talking abstractly in general. You know, we had a function, f of x, and if we took the derivative, we would call it f prime of x, and if we took the second derivative, or the derivative of the derivative, we would call it f double prime of x, and so on. So now if you're asked to do antiderivatives, you know, what's the antiderivative of f double prime? Well, the answer is f prime. And what's the antiderivative of f prime? Some function f. And maybe the function f is already the derivative of somebody. So if you're going up the ladder, what's the antiderivative of f? And we refer to that as big capital F of x. So I don't want to get too complicated here. I'm just trying to explain the relationship, the hierarchy of this notation. I guess you could say, what's the derivative of f prime of x? If you take his derivative, you're there. Okay, well, there's many more rules to discuss. In fact, I haven't really discussed any rules. I've sort of discussed notation here and the concept of the arbitrary constant. Let's add to this a little bit. So maybe could you integrate a cosine x? Well, you're looking for the Antiderivative, I mean, you're looking for, hang on, the derivative of sine x is cosine x. So what's the integral of cosine x? I think it's sine x plus c plus some arbitrary constant. Is that right? And then you could always check yourself, what's the derivative of sine x? Take his derivative, you get cosine. So what's the antiderivative of cosine? It must be sine plus c. So there's a lot of good rules. Here's a good one. What's the integral of e to the x? Well, do you remember the derivative of e to the x? The derivative of e to the x was e to the x. So the integral of e to the x is e to the x. That's everybody's favorite. To do these power rules, the main rule, so I just threw a couple up here, but the main rule is what we call the power rule. And so I'm integrating some x to some power. Now you remember the derivative rule. The derivative rule, power rule, was if you're taking the derivative of x to a power, you bring the power down, right, you bring the power down and then you subtract one from that power. The derivative rule. So the antiderivative rule is to do the opposite of that, the reverse of that, in the reverse order. So hang on, what did I do? I multiplied and then I subtracted one. Well then what I want to do here is I want to add one to the power, and then divide by that new power. So this is important. This is crucially important. This is the classic power rule for integration, or the power rule for antiderivatives. It's the opposite of the good old power rule of derivatives. All right, I got a lot more to say. That's getting you started. I might do another video here in a second. We're in the middle of 5.1. Good luck.